Good morning, my dear students, and welcome to this lecture series by AKtU. I am Dr. Supriya Furalatpam. I am an assistant professor in the Department of Civil Engineering in Bhavanasi Das Institute of Technology and Management, Lucknow. I will be taking your environmental engineering subject with code KCE 603. I will be taking unit 3, that which we will be talking about physical, chemical and bacteriological examination of water and wastewater, and this is my first lecture. Now, before I start the unit, let us first discuss about the syllabus. So, what you have to study in unit 3 is we are going to mainly focus on the physical, chemical and the bacteriological examination of water and wastewater, which will include temperature, pH, color and odor, solids, nitrogen and phosphorus, chlorides, toxic metals and compounds, BOD, COD, water requirement, standards for water and wastewater, disposal of wastewater on land and water bodies. So, in this unit we have to study the physical, chemical and the bacteriological characteristics of both wastewater and water. So, sometimes when we talk about temperature and when we talk about pH, for all the characteristics we have for water and wastewater, some things are common and some things are not that common. So, while I am taking this subject, taking this unit, I will be dividing, I will be first going for the characteristics of water and then I will focus on the characteristics of wastewater. So, this is the references I followed. So, the references are environmental engineering by Howard P.V. Then environmental engineering volume 1, water supply engineering by S.K. Garg, environmental engineering volume 2, sewage disposal and air pollution engineering by S.K. Garg. So, I followed mainly this textbooks. Now, coming on to the characteristics of water. As I already told you, first we will be talking about the characteristic of wastewater. Once we complete the characteristics of water, we will be focusing on the characteristics of wastewater. So, the characteristics of water can be classified under 3 heads. So, when you talk about, when you say ma'am, what is characteristics of water, I am going to say that you have to talk about characteristics of water in 3 terms, that is the physical characteristics, the chemical characteristics and the bacteriological or the biological characteristics. So, physical characteristics would have certain heads under it, chemical will have certain heads under it and bacteriological or biological characteristics will have certain heads under it. So, we will discuss this one by one. So, now let us come to the first characteristics of water, that is the physical characteristics of water. So, I have already told that we have 3 characteristics, that is physical, chemical and biological or bacteriological. So, when we talk about physical characteristics of water, what do we mean? Physical parameters or physical characteristics of water will respond are those which will respond to the sense of sight, means you can see them, touch, you can somehow feel them, taste, you can taste them in your tongue or smell it, right. So, these characteristics of water are the suspended solids which you can feel physically. So, the most important physical characteristics of water are the suspended solids, turbidity, color, taste and odor and temperature. So, we will take each one by one. Say for example, in this picture I have given, you can see that this water is dirty. So, how many physical parameters you can see here? You can see that color, right? You can just by seeing at this water, you can see that this is dirty. It has a very it's muddy. At the same time, you can also say that it's turbid, right? Because it has suspended solids. Why the turbidity? Because it has suspended solids. At the same time, this may also taste very bad. And temperature, how will you feel? Because temperature, if you have a cold water and hot water and if you put your hands on it, then you can physically tell, right? This is the colder water and this is the hot water. So, that is why all these 5 characteristics are physical characteristics. Now, coming on to the second picture, this is a lake which is infested with which is infested with copper, or you can say water from copper mines are coming and polluting it. So, that the color is this one. So, here you can see that this is both of these are polluted, or you can say this is dirty and this is polluted. Now, after this we will be discussing one characteristics, each one characteristics. Now, what are suspended solids? Suspended solids can be dispersed both in suspended or dissolved form. So, when you what is actually in water, as you can see, when even in wastewater, in wastewater or even in water also, आप देखेंगे कि when पानी से नदी से पानी आ रहा है तो उसमें बहुत सारी क्ले होगा एंड फ्लोटिंग मटेरियल्स होंगे, मे बी जहाँ से आए हैं. सो ऑब्वियसली दैट विल contain both suspended and dissolved solids. Okay. So, solids suspended in water may consist of inorganic or organic particles or of immiscible liquids. Inorganic solvents such as clay, silt and other soil consequences are common in surface water. Organic materials such as plant fibers and biological solids like algal cell bacteria are also common constituents of surface water. So, when we talk about surface water, some type of pollutants may be there in the form of soil or some bacteria or some even fecal matter, right. Other suspended material may be may result from human use of water. So, suspended materials are objectionable in water as it is aesthetically displeasing and provides absorption site for chemical and biological agents. So, what happens is that if I give you a glass of water which may be safe to drink, but if it looks dirty, you will hesitate before drinking, right. So, this is very important. So, people जो human हैं, हम लोग since we have this physical characteristic sense, like you can see and you can smell, even though that by drinking that water you may not fall ill, but you still won't want to drink. But you may want to drink a clear water which may have some microorganisms because you do not see them, right. So, that is the difference. Okay. So, suspended solids here we will be talking more of solids in chemical characteristics, because suspended solids which you can see, they will come in physical characteristics, whereas this dissolve will come in chemical, and this is more important because suspended solids can be very easily removed, whereas dissolve may require some more some extra efforts. So, we will be discussing more of solids in the chemical characteristics parts. Now, let us come to the second physical characteristics of water, that is turbidity. Turbidity is obviously related to suspended solids. So, what exactly is turbidity? Turbidity is a measure of the extent to which light is either absorbed or scattered by suspended materials in water. So, if you have suspended material in water like clay or some type of sand or gravel or whatever, that is going to look turbid, that is going to look dirty, like dirty dishwater, right. So, as you can see here in the picture, this is relatively less turbid and this has the maximum turbidity. So, increasing. So, this is turbidity is increasing from here to here. Okay. So, most turbidity in surface water results from the erosion of colloidal materials of clay, silk, rock fragments and metal oxides from the soil. Vegetable fibers and microorganisms may also contribute to turbidity. So, turbidity is measured by turbidimeter. So, there are 3 types of turbidimeters. First one is Jackson turbidimeter, Bailey's turbidimeter and Nephilo turbidimeters. this is not that much used. The most commonly used in the past was Jackson turbidimeter, and now we generally use nephelometers. So, what is in Jackson turbidimeter, what we do is we have a sort of a candle stand, okay, and we will lit the candle here below this. On this stand we are going to have a metal cylinder. This metal cylinder is actually nothing but a holder for a glass measuring cylinder. Which is graduated, it will have markings like this. So, how will you do? So, once we have to start the measurement of turbidity, what we will do is I will simply keep that instrument in front of me, and as soon as I have to start, I will lit the candle. Okay, this is the candle, and I will see the light of the candle from here, from the top. So, I will keep it like this, and I will keep on seeing. At the same time, with my other hand, I will simply put the turbid water, the dirty water on the gas cylinder. So, I will pour it here. So, it will start filling, but and I will stop pouring the moment I stop seeing the light of the candle. Okay. At that time, say for example, the water is at this level, right. Then what will I do? I will simply take the glass level out and measure how much is the distance. From this I will get how much is the turbidity of this water sample. Okay. So, what is the units for it? Units are NTU, that is nephelometric turbidity unit, and JTU, that is Jackson's turbidity unit. JTU is used for obviously this, and now we usually use NTU, which is nephelometric turbidity unit, okay, for true nephelometers. Nephelometers are actually more electronic in nature, and we are in an advanced stage of engineering. So, what we will do is we will simply you have simple small tubes, we will simply put those water on the tubes, and then we will simply put it in the instrument, and they will give the reading. Okay. Now, the acceptable limit for turbidity in potable water as per IS 1050/2012 is 1 NTU, whereas the permissible limit is 5 NTU. Okay. Before we go any further, I want to first clarify two things. What we follow here for the drinking water standards is Indian standards 10500/2012. All of you should read this. Okay. So, the code drinking water, for drinking water, the code we follow is IS 10500/2012. Okay. And another thing is, if you see here, there is one thing called acceptable limit and another is called permissible limit. Acceptable limit, when we talk about, if you take any code, then there is two terms in it, always acceptable and permissible. Acceptable means if the turbidity is of 1 NTU, so most of the people who are there is not going to object, and there is not going to be any health issues. And permissible limit is the maximum value which is allowed. After after a permissible value of after this permissible limit, this water will not be allowed. We won't be allowing people to drink it. It's not going to be potable after this. Okay, now one more thing here we want to here I have written here that turbidity measurements are normally made on clean water as opposed to wastewater. Why? Because obviously when we talk about wastewater, we know it is going to be dirty, and obviously turbidity should not be an issue because it is already known. But when we talk about potable water, we want it to be clean, we want it to be without turbidity. Okay? So, whatever turbidity measurements are doing, we are doing only for clean water or potable water, as you say. Now, let us come to the the third parameter, that is color. Pure water is colorless, but water in nature is often colored by foreign substances. So, but water as it comes, so for example, all your water, drinking water is most of the time you get it from rivers, right. Those are waters are disinfected and you get that in your tap for drinking. So, when you that water is coming, they have gone through some sort of place which has which will is going to give them some color. Water whose color is partly due to suspended material is said to be apparent color. Why? Because you can easily remove suspended material by filtering, right. Whereas, color contributed by dissolved solids that remain after suspended material is known as the true color, right. So, we have two types of color here, apparent and true. Apparent is due to suspended solids and true is due to the dissolved solids. Colored water is not aesthetically acceptable to general public for drinking, right. So, if someone gives you some maybe green color water or something, you won't drink it even though that water may be safe for drinking, right. So, you have this type of block in our mind. Color can be expressed as true color units or TCUs, where one unit is equivalent to the color produced by 1 milligram of platinum in the form of chloroplatinate ions, right. So, what is 1 TCU? 1 TCU is 1 milligram the color produced by 1 milligram of platinum in the form of chloroplatinate ions. Now, let us come to taste and odor. Many substances with which water come into contact in nature or during human use may impart perceptible taste and odor to it. Taste and odor. So, when it passes, it may give you some different types of taste and different types of odor. Taste and odor may be due to the presence of dissolved gases such as H2S, methane, carbon dioxide and oxygen. Combined with organic matter may be due to mineral substances like sodium chloride, iron compounds, carbonates and sulfates of other elements, phenol and other tarry or oily material. The taste and odor parameters are also associated with potable water, because obviously you are not going to drink wastewater, right. Then, and it can also be measured by threshold odor number or TON. It represents the extent of dilution required to make the sample free of odor. So, you keep on diluting the sample till you see that there is no odor coming out of it. Okay. Now, let us come to the last physical parameter, that is temperature. Temperature is a measure of the average energy, that is the kinetic energy of water molecules. It is measured on a linear scale of degree Celsius or degree Fahrenheit. Temperature is not used directly to evaluate potable water or wastewater. It is, however, one of the most important parameter in surface water systems. Why? Because temperature of waste surface water governs to a large extent the biological species present and the rate of activities. It also has an effect on the chemical reactions that occur in natural water systems. It also has a pronounced effect on the solubility of gases. So, this solubility of gases, when you talk about, you are talking about dissolved oxygen. Okay? So, if temperature is so, streams with lower temperature will have higher DO or dissolved oxygen. So, that the more oxygen will be available to the aquatic plants or aquatic animals and aquatic fishes which are living there. At lower temperature, rates of biological activities, that is utilization of food supplies, growth, reproduction etc. is lower. For potable water, temperatures above 5% are desirable, where temperature above 25 degrees are considered objectionable. Okay. So, with this we have finished physical parameters of water. In my lecture we will be continuing and we will be talking about the chemical parameters of water. Thank you. Thanks a lot.